Today discussing topic is losses of the transformers. If the transformers is a very vital part, so we have to know about what type of losses are in the transformers. So the first loss is the core loss or iron loss of the transformers, and the second loss is the copper loss of the transformers. So now we discussed about the losses. Core loss or iron loss, eddy current loss and hysteresis loss are two losses related to the core loss. And we just discussed about the hysteresis loss. What is hysteresis loss? The hysteresis loss is due to reversal of magnetization in the transformer's core, and this loss depends upon the volume and grade of the iron and frequency of the magnetic reversal and the value of the flux density, and it can be given by the Steinmarz formula WH equal to zeta Bmax 1.6 FV watt, where zeta is the Steinmarz hysteresis constant and V is the volume of the core in cubic meter. And now we discussed about the eddy current loss. What is eddy current loss? In transformers, AC current is supplied to the primary winding, which set up alternating magnetizing flux. When this flux links with the secondary winding, it's produced induced EMF in it. But some part of this flux also get linked with the other conducting part like steel core or iron body or the transformers, which will result in induced EMF in those parts, causing small circulating current in them. This current is called as eddy current. Due to this eddy current, some energy will be dissipated in the form of heat. So, this hysteresis loss and eddy current loss is totally related to the core design and the core material we used, and also depend on the frequency of the system. Let us now start the copper loss in the transformers. Copper loss is due to the ohmic resistance of the transformers winding. Copper loss for the primary winding is I1 square R1. If I1 is the current in the primary and R1 is the resistance of the primary, and the secondary winding, in case of the secondary winding, it will be I2 square R2. Okay. And it is clear that the copper loss is proportional to the current. So copper loss is proportional to the current. For I1 square R1 for primary and I2 square R2 for secondary. So I1 square R1 for the primary and I2 square R2 for the secondary. So from these equations, it is clear that the copper loss is proportional to the square of the current, and the current depends on the load. What is the current? Current is the load. Everybody know that the current is the load. What is the load? Load is the current. So the current depends on the load. Currents depends on the load. Hence the copper loss in the transformers, copper loss of the transformers varies. The copper loss of the transformers varies with the load.